From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
When you buy $1 million machine, the risk is high. You want to make sure that everything's well, everything's working. The whole company's on top of you, but the whole company took a big risk. And then the implementation risk is also high. If it doesn't work, if it does work, if you break the machine, if something goes wrong, the risk is high. With our machine, well, the risk is lower. So now you can let the engineers be a little bit more creative. You can let the prototyping people be more creative. You can let the machine be a little bit risky and not really know exactly how you're going to use the machine, because the business case doesn't have to be as rigorously closed.
That was Juan Mario Gomez. Juan Mario is the CEO of Xact Metal. Xact Metal is a startup out of Penn State, developing a lower-cost direct metal additive manufacturing system. As opposed to traditional direct metal systems that can cost upwards of $1 million, the Xact platform is a fraction of that cost, with the aim to lower both the financial and risk burden typically required to invest in these types of technologies. Prior to running Xact Metal, Juan Mario was at GE for 15 years. He joins the show today to talk about the need for lower-cost metal systems in the AM ecosystem and how it will impact not only the next generation of companies using 3D printing, but will enable access to the technology in a much more hands-on way. All right, Juan Mario, welcome to the show. Do you want to just get started with a little bit of background for the audience?
Sure. Thanks for having me. I'm kind of excited to be here. My name is Juan Mario, or Juan Mario Gomez to be formal. I'm the CEO of Xact Metal.
Perfect. And what is Xact Metal? How did you get started there?
It's a good question. So we started the journey about 4 or 5 years ago. I met a young engineer that had just graduated from Penn State, and he had the idea of doing multi-metal printing and wanted to do multi-metal printing as a next generation of technologies that could be available. And it made a lot of sense, right? If you could have color in 3D printing, metal 3D printing, it gives a lot of design freedom to the engineer. So when Matt was trying to start this idea, he approached people and nobody would give him access to a machine. Nobody wanted to modify the $1 million piece of equipment and let Matt tear apart and do what he needed to do to metal 3D printing. So Matt, being a hacker and a maker, decided, well, I'm going to try to do this on my own. What's so special about these machines that we can't really print metal versus just printing plastic? And so he started the journey. I started attacking the laser, then just started attacking the galvanomer mirrors, as well as the theta lenses, and started realizing, well, those are the most expensive components of the systems. Let's start getting rid of those. So through really hard work and a little bit of naiveness, he did it. He came out with a machine that printed metal. And so when I met him, he had a machine, super basic. It looked like an experiment completely, but it printed metal. And so we started talking about that, and we started. I had just left GE. I had been there for over 30 years, nearly 30 years as an executive in a lot of technology product companies. And I was looking for an investment type of thing, but not really looking for an operations type of thing. And we started talking, and we realized that we could both work together to maybe, instead of doing multi-metal printing, pivot towards bringing affordable 3D printing metal machines into the marketplace. When I was bringing very high, expensive equipment in the past, in things like X-ray CT for industrial uses, the machines were very expensive, and it was great value. It was incredible value for people that were able to use them, but not many people could afford them, and the prices needed to come down. And I saw, together with Matt, that the same thing was present here in additive manufacturing, in particular in metal, that the value that these large companies that had metal systems was truly unique. The ideas that we talk about 3D printing were truly being brought in metal, but the machines were just too expensive. And so we launched the whole company with the idea, with the premise, with the hypothesis that people needed less expensive machines. And that if we had those, that people were able to then print in metal and start getting those value propositions to themselves, and therefore expanding the application space, the number of engineers and the number of companies that could really afford the technology. So that we pivoted, we launched XactMetal. in 2016 or so, 2017, I should say. And it's been a kind of fun ride since then.
Yeah.
Yeah.
And your machines are almost a tenth of the cost of some of the big platforms out there today. And
It could be if you combine them to a large system, like let's say a mid-sized volume of 250 by 250 or something like that, 250 by 250, 250. Yeah, it could be. Those machines are typically $1 million. Our machine, or something like that, between one laser, 4 lasers. Our initial machine is a smaller volume size, so it kind of in the smaller size of the volumes, but a pretty nice volume at 5 by 5 by 5 inches, or 125 by 125 by 125 millimeters. And in there, our pricing point starts at sub 100,000, and so it's really not a consumer type, an industrial consumer type printer. It never will be in powder bed, but it because of the complexities of the powder. But it is kind of start getting to the more accessible points of a company. Typically, what we find is when you have $1 million machine, you're either betting the company's future if you're a smaller company, or you're betting a big chunk of the strategy of the company in that technology decision. When you're in the $100,000 price point, you really are now betting that year's capex budget, or for a small company, a small medium enterprise company, and really, it's a lot more affordable and doable for a lot more people to execute those budgets. They're not as risky as the larger budgets are.
And what are the trade-offs that kind of come with making a smaller printer? Like, what do your customers? I mean, obviously you can't. It's not as big, but does that matter to the companies you're working with?
Well, the size is not a restriction. So size is just a restriction of that comes with price. The real we have plans to develop a mid-sized machine typical to these larger machines, and with the same idea of much lower price points. The restriction comes in regards to, well, I'll put this a little bit different way. The restriction, what we try to make sure that the printer was not lower performing in terms of print quality. In metal 3D printing, having a pretty part is not good enough. If you want a pretty part, you print it in plastics. So it has to be a functional part. It has to be a part that does a function, and it needs to be a function that needs metal. And so you must have the requirements that in terms of the performance of the printer that meet those of current metal 3D printers. If you have parts that are too porous, if you cannot get the densities, you cannot get the heat treatment that you need to be able to have the hardness or the stress levels that it can sustain, then the part's useless to the customer. So for us, we cannot compromise on part quality or print quality, and our machine doesn't. Our machines will look the same as those of more traditional brand names that you would see in the marketplace. SLM, Reddish, IEO, so very established players. The machines will be, you could not tell the part away from each other. We do sacrifice a little bit on print speed. We have, instead of having a galvanometer mirror, we went after an XY scanning concept, similar to a plastic printer would do. So instead of moving the filament, we actually just moved the mirrors and the lens. The laser is a fiber laser, so it's the same type of technology used in the larger machines. And we move the laser beam, not the laser head, but the laser beam in a flying optics combination. And that allows us to move extremely fast, in the order of 600 to 800 millimeters per second when we're fusing. But we carry heavier inertia, heavier weights. Therefore, we have a little heavier inertia. So when you have it takes a little longer to stop and a little bit longer to accelerate back to fusing speed. And when you have parts that are very intricate, then we're a little bit slower than a Galvo-based system would be. And that's really the only negative part of our system, I would say, in a very positive word. There's a lot of benefits that come from our system, because by getting rid of Galvo, the machines are smaller, they're much less compact, we use modern electronics, modern designs, we are always normal to the powder bed. That allows not to have fusing geometry variations across the powder bed as you're fusing with the Galvo. So there's some benefits that come from our technology, but there is a little bit of a speed compromise that we need to work with the customers on, and understand if they really, really must have speed, then maybe they need to buy the more expensive machines.
Yeah. And I think of speed in multiple different ways in the context of 3D printing, because you have like you were saying before, some of the conventional metal machines it's a big investment, and it's usually a long investment where it could be you order a machine and it's a year or 18 months before you have the facility outfitted to work on it. And then it's intimidating. I mean, for anyone that like, oh, I'm working on $1 million machine here. Like, I don't want to mess up any builds, and just the rate of adoption is probably slower than it could be.
You're completely right. I'm a risk guy by background, so I see a lot of risk. I see things in risk side of things, and I see that as risk. And so when you buy $1 million machine, the risk is high. You want to make sure that everything's working. The whole company's on top of you, but the whole company took a big risk. And then the implementation risk is also high. If it doesn't work, if it does work, if you break the machine, if something goes wrong, the risk is high. With our machine, well, the risk is lower. So now you can let the engineers be a little bit more creative. You can let the prototyping people be more creative. You can let the machine be a little bit risky and not really know exactly how you're going to use the machine, because the business case doesn't have to be as rigorously closed. This pricing points creates a lot of flexibility. One of the things that's important for us is we actually think that metal 3D printing is still in the very early stages of adoption. When I go to places like FormNext or Rapid or one of these 3D printing events, AMUG, they're exciting. They're very exciting, and of course, everybody there knows about metal 3D printing. But then I go to the industry in general. I start saying, well, how many of you have seen a metal 3D printed part? And they say, oh, you can print metal. And then I say, have you ever seen a machine? I say, well, I didn't even know you can print metal. So that we feel that the industry, though, in such segments of the industries like aerospace and medical, maybe in rocketry, yes, very accepted and very known. But even in those industries, very few people know that this is available. And what we're trying to do is really change the paradigm. A lot of the people that have been using industrial plastic printing machines today to start the journey into metal, which means that they're going to start the journey not into producing the next rocket that's going to go to the moon. They're going to start with the early things that the whole industry has done, which is prototyping and tooling applications. And so we find our machine is perfect for that entry point because it allows them to start their journey. What does this machine do? What can it do? What can I print on it? Where are the strengths? What are the weaknesses? And start that learning process that then allows us to start thinking about implementing higher and higher applications.
Yeah, and you hit on a really important people issue as well. And within these organizations, like or within general manufacturing, there's a stratification where like there's the edge case of people who have metal printers and have been invested in it for a number of years. But even within those companies, you find that it's only a handful of people that actually know what's going on. And so like for it to expand out of certain groups or certain cohorts of a given company, it's often very difficult, even if you have the investment behind you, because you can't get enough people exposed or involved at a detailed enough degree to make an impact. And so it's a challenge.
It's a huge challenge. So we actually see two segments of groups in what you just said. We see the small medium enterprise, the small medium enterprise that could never afford a machine. We see this type of people now starting being able to afford the journey to come into metal 3D printing because our machines are now more affordable. Hence, they can actually be brought into these type of operations. There should be a metal 3D printer at every machine shop in the world. It should be just one of the tools in their tool sheds for them to be able to supply solutions to their customers. And it needs to be a complementary tool to what they use, not a replacement or a threatening to the technology they're using. It's a complementary tool that allows them to do more value to their customers that they've known for many, many years. So that SME, that machine shop, that R&D department, that SME needs these type of tools to be available to capture the benefits of 3D printing. On the other spectrum, it's just like what you said. I'd like to use, we happen to be located next to Penn State, in Pennsylvania. It's a fantastic location to be located. We're next to Sim3D, which is one of the nation's premier 3D printing labs in the United States. And we're very excited to be located here. Great location to be located. And when I started learning about this issue about adoption of the machines within large organizations, we started realizing that Penn State was a great example. Here's a premier university, one of the top 10 universities in the world in terms of engineering, one of the universities, top 10 universities in 3D printing and material science and everything. One of the top 10 universities in patent development, patents in the world. And they only had one metal 3D printing facility. 20 campuses, 100,000 students, and one metal 3D printing facility completely booked with high-paying work being done by people for the military and for larger companies and things like that. So the machine was, like you were saying earlier, completely inaccessible to the larger organization. Now with our pricing point, we now have a machine at the Learning Factory where it's being used by students in their senior design thesis. So now they're getting trained, and the next generation engineers have this tool available they can use where they're starting to do their senior design thesis to be able to be accessible to them. But what's more important is that and we have now 4 or 5 opportunities that we're working through the Penn State network. You see that diffusion and within larger organizations to be able to be affordable and decentralized within the organization. One of the restrictions that we see is, maybe I'll put it another way, one of the things that we see in the marketplace is that we have these very centralized labs, very large organizations, and the technology is risky, not many people can do it, so they centralize it to one location so they can start adopting it. But that centralization strategy is a barrier to adoption. It's a barrier to diffusion of the technology. One of the things we're trying to do is really what we're doing here at Penn State, which is to decentralize the technology through the network. So it can be located next to the engineer, it can be located next to the researcher, the manufacturing floor, the service department, the tooling department. These are the people that need the tool, but they can't afford the tool to go to a central lab. They really need it next to what they're doing.
How does that translate to your actual business model when you're kind of looking to get into so many different locations and reach different environments that not just at AMUG or Formnext? Like, how do you get to kind of more local distribution of your product?
It's a great question. It's one of the things that's really exciting is the 3D printing industry. It's just a modern, hip, industry 4.0, super techie industry, communicates via social media like crazy. It's really, really exciting to do. So there's 2 things that we're doing. One is we're trying to communicate a lot more through social media. We're trying to communicate with through vehicles where the industry, the young engineers that are coming into space, she or he need these type of technologies, and they want to learn through these type of media. So we're trying to engage them and promote the message through digital media type activities. Yes, going to trade shows on this activities where we meet a lot of people, where we really start connecting in the journey of assessing going from plastics to metal through social media. So we see a lot of development there, trying to reach this new type of customers that haven't been reached before, but are very active in the plastic side. The other thing that we're doing is really, if we're really going to be able to support customers around the world with a local product, we need to be local in what we do. So one of the things that we've done is we've gone 100% in what we call indirect. So we not only do we sell, which is important to be able, I like to say, we sell in Sweden in Swedish, we solve the application in Swedish, we install the machine in Swedish, and we service the machine in Swedish. And that's very, very important, because if we're going to support these small, medium enterprises, these decentralized organizations, they don't speak English. They don't speak, and they're also halfway around the world. So they must be serviced in a way that they can then be successful. And they don't have, when you have $1 million machine, it's okay to wait for the OEM or the factory to wake up. But that's not okay when you have a $100,000 machine. It must be local service. So we've gone 100% indirect in that, and we're very excited. We partner with large distributors that are in the industrial plastic space. They have local and, more importantly, service organizations that can support the customer locally. And we started the journey with their customers who are moving from plastics to metal now, as opposed to, we're not trying to go to the people that have 20 metal machines already. That's not the people that we're really talking to. Their solution has been met. We're trying to meet the 10, 20, 30, 100 other people that are there that are have plastic machines. They're doing industrial work in plastics, but need a solution. And we're doing that in the local ecosystem of that customer and the local service of that customer. It's very important. I can't tell you, when I was at, it got me so upset sometimes in my prior careers, when we had a global business and somebody said, wait, we have to wait till the Germans wake up, when Germany is where we had the factory. That was so frustrating because it indicated to me that we had not done a proper job in localizing to be able to support our customers in a local way.
And how much of your job or the company's job is also educating kind of these new entrants into metal 3D printing about how the process works, powders in general, support structures, design, all of that kind of comes into play when you're using it?
It's a lot. And sometimes you feel like a politician in a sense, that you go someplace and you say the same story all the time, but it has to be. I mean, what larger companies, you take the industry leaders that have been for a long time, EOS, SLM, for them to go see a heat exchanger being printed, it's kind of boring. Oh yeah, another heat exchanger. Frankly, a heat exchanger being printed in copper is super exciting to our customers because they've never seen a metal 3D printed part. So we just bring we're not trying to, we try to bring these new technologies that are news to these customers to them. And we have to say things that maybe are, oh, I know you can do that, to them, but our customers don't know that. So we have to kind of say the things that they didn't know before and educate them. And it takes effort. Luckily, through the fact that we're distributing through these type of distributors, we're not on our own. We really have over 30 partners. Next year, we'll have over 50. And we feel very comfortable that we are able to reach them and educate them in their application problem. It has everything is about solving the application. And we can't have a metal printer and not talk about the customer's application problem. So we have to show them we can meet your application. And for them, it's going to be the biggest thing in the world. And that's great because it is. But it may be, well, for somebody who's in metal 3D printing, well, we could do this 20 years ago. Yeah, but not to this customer.
Right. Yep. Yeah. And for kind of your customers, emerging customers, where does that conversation usually start within the companies that you're talking to? Is it kind of the engineering team kind of finds you, or is it kind of the CEO of these small, medium-sized companies like, hey, we want to get into 3D printing, but now it's more accessible to us? Where is it kind of ground up or top down?
It's both. Sometimes we come and somebody says, I heard about this, and gives it to somebody to go study. Or sometimes it's the engineer trying to just learn about it, wants to start the journey. We need to help that engineer promote that message through their company. So it's really both. But what we are finding is that we're trying to target, maybe I'll kind of put a marketing head on. We're trying to target 3 different types of personas. In what we try to do. We see that we're starting the journey from plastics into metal. We're not going to start with, we're going to go right into the production line with your most critical part, and we're going to do 100,000 parts a year. That's not going to be the discussion. The discussion that we have with our customers is, let's start with the persona of a prototyping customer that wants to go into prototyping metal, has been prototyping industrial parts for their company, for plastic industrial parts for their company for some time, wants to start the journey into prototyping metal parts for their company, for R&D, for development, for things like that. So we're trying to start the journey with these prototyping customers, which is frankly where a lot of the technology is really ready to be expanded on, but it hasn't been really expanded as much as it should because not many people know about it. Then we see the tooling customers. Metal 3D printing is a game of a high mix, low volume. Metal 3D printing is even more. High mix, low volume is the way to go. Tooling is a perfect example of high mix, low volume. We just did a post about grippers and fingers and jaws at robots. Hundreds and hundreds of parts need to be produced, extremely expensive to be produced every time in traditional methods. And here you have print them on demand, put them on the robot, keep going through the metal side. And now these printers have the capability. So a second persona is this tooling customer who's been using plastics to support the line, but really needs a little bit better performance that comes through metal, either by having a very strong part that can support the stresses or having a friction part that can support the wear. And sometimes we find them combined. We find that the tool combination of a plastic printer and a metal printer combines a even better solution that the customer couldn't design before. So that's the second persona. And the third persona is a little bit what I know you're very passionate on, which is this technology is fantastic, is incredible, but there's not many people that know about it, and less people that actually know how to do it. So we've been, the third persona that we're going after is the people who are very passionate of bringing educated the next engineers, the next technicians that need to run this equipment. Today, the equipment is being run by PhDs. That cannot be the case. And I'm exaggerating that point to make a point. That cannot be the case. We need this technology to be super easy to use so that a technician with a 2-year degree can operate this machine, and that's it. I mean, even a high school degree. This is what we need to do. I was very excited. We just hired about 1.5 years ago, maybe almost 2 years ago, we hired one of our application engineers. She's fantastic. She's just fantastic. And she came with a plastics background. And within 1 month, she was starting to run on her own, completely independent, not just a part, but talking to customers, or solving their application problems. And we did that by really making the machine super easy to use. Has to be easy to use. The whole workflow has to be easy to use. And people need these solutions so that these personas, the training persona, the person that's trying to educate at a university, at a tech school, at a high school, trying to bring the next generation, we need to give them the tools that they can have so they can actually educate and give us this type of people that we need to support this very high growth rates that metal 3D printing is going to have. These three personas, remember, I didn't say production people. I just said prototyping, tooling, and training. We really are focusing these 2 areas because we think this is where a lot of people are now starting the journey into metal.
Yeah, and it's so powerful, the idea of giving access to to this technology that's going to be a platform that's going to be impacting so many different industries at a level where someone can walk in 2 weeks, 30 days, can get a firm grip on it, how does it work, and be competent enough to even scale that, like to running 5 machines or a bigger machine and
get a job doing that.
Right.
We need, if this technology is really going to be at every shop. COVID, we're going through COVID right now, and it's very difficult. It's really hard for not only for the whole world, including the metal 3D printing industry. But we'll pass COVID, and the growth rates that we saw before are still there. The need for our product is still there. But we cannot grow at the growth rates that we expect to grow if there's not people to run the equipment. So there's a lot of passionate people doing a lot of things at universities, at tech schools, at high schools that know this and are trying to kind of change the curriculum to be able to not teach theory, but teach practical things so that the people being trained can get great jobs, great paying jobs, technology jobs, manufacturing jobs that are globally competitive. We need to give them a tool. They can't buy $1 million machine. They need to buy a machine that's more affordable they can bring into the budgets, and they need to buy multiple so they can train more than one person.
For sure.
Yeah.
And you mentioned, kind of switching gears a little bit, copper and kind of one of the previous questions, but kind of, can you talk a little bit about the types of materials you're printing and available?
Yeah, people get really excited about metal 3D printing, and then they say, "Can you print this and can you print that?" And then I see their face going like, "Oh, that's not that exciting." I mean, with metal 3D printing, in particular, our metal 3D printer, which is powder bed. Some people call that SLM, DMLS. We do metal powder bed fusion, in particular laser metal powder bed fusion. And so we need 2 things for that to happen. We need powder that is metal that's in the form of powder. And so it has to be powder of 15 to 45 micron, 60 micron size particles. It needs to flow very well, things like that. And if we can't get powder that way, we can't really put it on machines and use it. So there's a restriction on that. And then the second restriction is that it needs to be fusible. We use the laser now. As you know, we melt or we fuse the powder on spot each layer gets fused to the prior layer, and that's how we build the part. So we need those type of things to be available in the type of solutions that we have. So typically we see a lot of 316L stainless steels. We see 17.4 stainless steels. We see tooling steels in the tooling applications that we talked earlier. lots of demand there. We see also things for high temperature type of things like Inconel 718 or 625. We see this type of applications. One of the exciting applications that we're trying to do now is in copper and bronze. I'll talk more about copper than I will about bronze, but copper it's very exciting. The packages that you see today in your iPhone, in your phone, for example, in your computer, getting extremely tighter all the time, tighter, and they're of course, and they're getting hotter. They're running more heat, more energy through them. They're getting hotter, but they're getting tighter. So there's a need for very tight heat exchanger packages in these very complex electronic systems that or assemblies that need to heat out, and it needs to be in a 3D contour space. And so being able to print 3D copper, print copper in 3D printing is very, very important. The other application that's exciting is antennas. The antennas, no longer do we take a stick out and talk on the phone, the antenna's embedded onto the phone. And it's shaped within the phone. And we need that antenna concept is very, very deployable by many types of things in the wireless devices and things like that. So being able to print copper was one of the things that got us really excited. We recently did it. It was not that easy. When we first printed, it's so reflective that when it first printed, it started melting our machine. So, ooh, this is bad. But of course, we were able to solve that through better heat management and things like that. And we're very, very excited about that type of application because it really is hitting to the core or the value of 3D printing, where not only can you make a part that you couldn't design, that you couldn't make anymore, whatever, now you're making a part that you couldn't physically design before or make before. Now you're doing it in a way that it brings you a lot of value, and all you have to do is simple modifications and know how to design for additive, and then you can get the part printed in applications that are really needed in the marketplace.
And as you were kind of scaling up your materials program, a lot of the challenge in the industry that I've seen is like, how do you compare your materials to other platforms, or what's that right mix between marketing and kind of like applications for specific industries?
Yeah,
I'm always curious of
that's a very complex question, and then maybe I'll answer one way, and if I didn't answer quite what you wanted, just ask it again. I think there's a couple points. One, we see that there's people that make machines, and there's people that produce powder, and there's people that frankly make software. And not everybody's good at everything, and not everybody really makes everything. And so I think that as the industry starts getting bigger, you'll see increasingly specialization of that type of stuff. When the industry was young, and there was a metal 3D printer, well, the volumes were so low that OEM had to also produce the powder, and that was important. But as the industry gets more specialized, it's really hard to see the economies of scale need to kick in, and the pricing points need to come in a way that allows the powder to be more affordable. We don't make the powder, but we do sell powder. But we use branded powder, for example, from Praxair. We say our powder's from Praxair. This is the value. We provide a solution to the customer that's very clear, and the customer has prototyping to applications where the volume is not very high. They're going to get a great solution from us. But we recognize that the powder is not from us because we don't produce powder. So if the customer has very high powder use consumption, they of course are going to be able to look for, they're going to want to and be able to look for a better price point. So they'll be able to go after that. And our machine is open powder. So, okay, if we can add value in the solution and make a customer started, and if we add value through that, great. But as the volume starts getting up and then going up higher and higher, then the customer is going to require better pricing on powder, and that's okay. And so we let the customer, not only let the customer, we encourage the customer and work with the customer to find a solution for them. That's very important. The powder is the key to the system, and we need to find ways to make that less expensive. We're doing all we can to make the machines less expensive. Another handicap in the marketplace today is the price of the powder, and I see that coming down very quickly over the next 5-10 years.
And so we're getting into the end of the year here, just a couple of weeks left.
Yeah.
Kind of as you run XactMetal into 2021, kind of what's on the top of your mind for the next year?
Oh, it's COVID. I said COVID was a little bit difficult. I think not only for us but also for the whole industry. Yes, there was a lot of. I think 3D printing was able to help in a lot of things that were needed around COVID, and that's absolutely phenomenal. But the industry is kind of like pause a second while people, it's just the whole economy slows down. But it doesn't. When the economies restart, the need for 3D printing hasn't gone away. It's only but even emphasized. But what the vulnerabilities that were found in manufacturing lines, in R&D departments and stuff like that, where they need the technologies next to the whatever the function is. And I think the need is going to be only but magnified in post-COVID environments. So for us, first we need to be able to continue to support this global expansion that we've been going through in this last several years, and do this in a way that we can't really be local everywhere. And the focus is going to be for us in that commercialization activity. We are also working on trying to get machines that are larger build volumes with higher performance, and bring the pricing points, continue to bring the pricing points down, but in larger build volumes. And we also are working down on trying to get the machines to be less expensive, even on where we are now. Because there are pricing points, there's still people that cannot close the business case. And the more that we can help customers with lower pricing points, the more the business cases are going to be closed, which means that more and more people are going to be using 3D printing. I don't think that we'll ever be in this consumer space, a prosumer space that sometimes people call. I don't think powder bed fusion is going to be ever there because of the powder and handling the powder. But I do think that there's a lot of spaces where they can use a printer in the $50,000 price range. And so we're working on kind of both sides of the spectrum, trying to bring new technologies to the customer and then so commercialize ourselves on the strategy that we have, bringing the products to our customers on a global basis.
Well, I, for one, am super excited of what you guys are going to keep doing. And
thank you.
Wanted to thank you for joining the show today. And we'll point to your website, and everyone can keep an eye on what you're doing and what you're coming out with. And thank you so much for joining the show.
Thank you for inviting me. It's been a pleasure. Thank you.
Right.